So without updating the title, I'm pretty sure the YouTube transmission doesn't work. Although now I seem to have the same issue, but now it works, or no? I don't know. Okay, it works. Okay. Okay. So, this was a very quick stream start, and the reason is I was just watching the VOD of yesterday's stream, and I made me want to do some things here. And one of them is in the for loop. What was it? Think about it. Definitely would want to do compile time resolution as a thing that we do. Mm-hmm. Okay. It was something else though. It sucks. There was something that I seen on the VOD that I wanted to immediately correct, but now I can't really remember what it was. Maybe it was related to the type scoping in PopN. Don't know. Anyways, let's work on pre-computing values. And the way it will work is I'll say, I think the resolver is what I would do it. Is I would have a static runtime value, or maybe bool, and we'll say pre-compute version. We'll say the resolver expression type scope run. What do I use this for? Okay, this is for just those. And I think it sounds fairly simple. Just say return false by default, right? Return true. Okay, and now instead of resolving here, we compute the result value. Maybe what I would say is say expression result, and we would say variable type. So basically, you would have it here, right? And we'll say compile time none, maybe, and runtime value. Yeah, I'll say is computed or was computed, right? And this I can just have here. Okay. Now this means that result type I have to change to be result type like this. Certainly not a good idea. That's something I could add here eventually, but I'm not gonna pre-compute functions yet. That's something I will deal with for now. For now, just simple expressions is what I'll do. Yeah, I should have used find whole word because now it's a bit too aggressive, but whatever. Okay. Now the resolver will say, let's say return false by default, and we'll say static bool compute. Oh, oh wait, this is not the function I'm looking for. Pre-compute expression. Runtime value. Expression result was computed equals true, and the value is the value. I'll say set expression result. That's what I'll do. And now, okay, in print, what we are looking for is, and I guess maybe what I should make sure is if so pass a resolver. This will be convert to runtime time. So if they aren't, if they're different, I would probably say resolver error. Server expression token account set expression result correctly. Likely a compiler block. Okay. And now here, what we return is I kind of like this framework because it'll simplify a lot of things, actually. Function call. So here, what I would do is return pre-compute expression, resolver, expression. I know, sorry. Set expression result. And the value would be a runtime. Value equals this, right? Value and equals expression print expressions. Okay. So you'll say here is count equals 0. It's kind of stupid. I have to count them again, but whatever. I think what I will do is actually after we. This is in the wrong place. Should be here. After we resolve the expression is when I would always just call Here I can probably return, right? But otherwise, if we have not found, I would say expression x comes like this. And here I actually don't need to error out anything. Here this is just count and value type equals var type int. Right. Okay. So it require us to include Kai runtime. Bind up. And runtime defines the binary eval bind up as a thing, right? Say it here, eval bind up. Even it up. Up B. And one other thing I might need is the conversion from. It's probably in resolver actually. Requires an executed. Hmm. I could make a fake executed for compile time, but do I want that? I don't know. We'll see in a sec. For now, let's just make it like this. Temp. Ah, I'd have to even make a run. Yeah, that's all stupid. All I need really is this to be an exec thing. I think that just necessitates us to have like an error handler or something. Let's make a file. Dialog. And we'll make a strike Kairos lawyer, and we'll have a const char prefix, maybe stage. Um, Mm. How do I write this? Need to pass it the logger. Close charge stage. Also, I think all of them would be nice if we had support for the oligarchs finally, but probably want this. Okay. Maybe actually I'll say electric here. I'll say it like this. Let's hope that's enough. Lawyer type. None. Lecture. Equals lecture, and here we would say similar thing. We would just say first debug node equals this. Like this. Okay, so now let's just write a simple. We'll make it a static. Move it here. Kairos format buffer 124, and we'll say what we need is we need var x va array v list va start va info, right? Va and va. This actually needs to also be v as printf, I think. And the list would be info is the format, list is here. Okay. And we'll just say printf %s, and we'll say logger stage and the format buffer. Okay, and we'll also say info here, right? Warning, error. And this probably can always just be called format. Yeah, okay. Okay, I think that does it. And now one thing is if token, we'll say print like token 9 token, else if logger lexer. Actually, this is all I need. I don't even need this. That's good. Not sure I need those. We print lex token logger lexer current, right? And otherwise, if logger there's debug node is when I would say that might be, I don't know, print time. So this is actually something I need to grab from here. Debug, no, wait, one. Debug, no, we'll say debug. Node, okay. I should actually pre-declare those, lexer debug. Maybe I should always just fucking use this. Maybe that's fastest, because that just compiles, right? Don't know. Huh. Sorry, because they have different kinds of logging, but I want to reuse the code. Save thing. Actually, what I need to do is have an executed here instead. And now in the parser, no, resolver. Where was it? Component, right? This can stay as it was. Same here. Well, just make it like so. We'll just pass it everything, and that should be good. Okay. Executed. Have it like this. And this helper function might still like use, right? Also, one thing that I maybe want to have here is add errors. Say logger add errors equals true here. I don't know. This feels stinky to finally have this Kairos log thing, but seems necessary. Yeah, all the back pointering. So silly, shouldn't need to happen. So now when we make a lecture, make lecture. Yeah, I kind of like the idea of having init functions instead of make functions. So I'll do that. And we'll also init Kairos logger lecture 0 lecture. Right. Parcel also has its stupid fucking. I hate this. It's just stupid. This parser stage, right? Now resolver stage needs to have its logger. Init logger, resolver, logger, 0, 0, resolver. Yeah. I don't fucking know. This is so stupid. Oh. Hmm. Hmm. Why? Why? Why do we have to make this stupid? And resolver I can just remove, right? But parser I kinda need to keep. We'll say Kairos or log. How did I name this? Is it Kairos? Yeah, Kairos error. Parser logger. This can just be 0 and error would be the error. As this allows me any kind of formatting, which is a problem. Yeah, this is not something I wanted to worry about, honestly. At this stage, but whatever. Hot errors is something I would just remove. And I want to init the logger for the parser. Just actually want to parse the lexer to it. And that's good enough, I guess. I'm not sure how I will do panic mode yet. Yeah, I guess for most of them I could have just used the odd symbol, but Backup token. Is this used? It is. Okay. The reason why you're passing it by a pointer is because it can also be optional, so you can just say 0 for the most part. That part of it I like. I can definitely see that the having so many copies of the logger state, which should really not have to exist on the runtime, is very stupid. Should be like C++ has nothing really, nothing sensible to allow you to like have compile time only state. But that would really be great. I think. I mean, you could do like templates, right? But that would probably suck. Honestly. Okay. So runtime error is probably just... Oh, there's no runtime errors anymore. I think what I want to say is... in the logger state... I'd also want to say like... bool log only... stop logging after error would be a state. Maybe what I say is enum Kairos logger flats, right? Let's say stop logging after error would be one. Right, and another one would be actually there wouldn't be another one, so maybe it's fine to just use a pool. Or maybe it just would be hard errors. I don't know though. We'll use booleans for now, and we'll also have one for bool mirror. Out had errors. Is that necessary? I don't know, but it's kind of annoying. We have to do that. Anyways, let's see. Huh. We'll need to add those. It's kind of stupid that we even have this init function. I know we don't do it ourselves, but at least that catches more errors than if we hadn't done that. Eventually, right? Because if I ever refactor this will be, the error will be shown everywhere. Which is great. Okay, and now if out had errors, we would say, yes, we had them. Okay. This would need to be logger. In the case of Lexer, we don't want to stop, and we don't have an out had errors, right? parser will stop after logging, and it has a parser tonic mode, right? Yeah, okay. I think that does it. Okay. Edit Kairos logger. Resolver will stop, and it doesn't have a panic mode, I don't think, right? I think we don't need this, honestly. So what I can say instead of panic mode, we'll remove this. We'll say parser logger, and we'll say we'll just have an error add any errors equals false. And now if the logger had errors, say had any errors equals true. Had errors. Say this, right? And then we'll reset it here. And now you'll say if we hadn't had any errors. Right. Okay. It kind of starts to look sensible. And now for exec, that's where we will say when we create an exec. Okay, I think what I will do is I will have a static void and an exec, arrows, exec, right? Or rather execute it. Exec runtime equals runtime. Right, and we'll also have an init. Kairos logger. Exec logger. 0 exec. Let me see runtime. And do we stop logging is the question. I don't remember if we used to. We did used to, okay. Yeah. And I just need Kairos logger here. Hot errors can be removed, okay. Like this. Okay. This is so tilting, honestly. So now I have to redo those here for a different file. Okay. Exec error, exec. Huh? Okay. Kairos one, exec loader. Token is 0. Okay. We have refactored. So let's say refactor logging, allow formatting. Um, allow calling from any or standardization between stages. Yeah. So yeah, those are two things. And what that allows us to do a lot of refactoring for not so much of immediate gain, maybe, but it's a better API. Although the fact that I have to clone the logger so many times, which is not a small amount of stuff here, of things, it's pretty unfortunate. But so this is like 24, 26 bytes, right? See? It's 32. Wow, yeah, it aligns to next 8 because of the start, I guess. That's silly. One sec. Okay. Let's see if we have anything running. Actually, we shouldn't really have any. Oh. One problem here is that we don't have a new line here. Okay. This is probably every print in existence. But we do seem to have correct thing. And actually, I can even say I cannot Kairos here to the stage printout. It's kind of neat. Kairos resolver. Okay. That's neat. But in resolver, when we pre-compute, there's some issue with this, and I think see what happens. It is an integer, and this type. Oh, that's stupid. You should compare to the value type. Okay. So here I think. So why did we even do this? Is because now I can have a logger here instead of exec, right? Now all I can pass here is the logger. Logger like this. Maybe I undev here. Undev. Logger. Same here. Logger. Logger, which makes it standardized between the stages, which is good. Now when I go to resolver, I can now expose those two, right? Wait. Should be runtime. Runtime, okay. And now Kairos logger is what I'm looking for. Logger. Yeah, I'll just use the resolver logger. I'll say expression binary up left. Expression binary up right. So now actually what we'll again is static runtime. Static runtime value. If or compute or rather get result value. Okay, so now if it's computed, we return it. Otherwise, we return that. Maybe what I do is actually an address because that's optional, right? If it was computed, we'll say that, and now we'll say runtime value a equals get the result value of this, right? Same for right. Now, if A and P, that's when we actually that should be called set result value, I think. Set result value. And actually, funny thing, this doesn't need to be a bool. Because we're actually doing a post-tree traversal, right? So this is not on its own recursive, it's just called by the recursive function after all of the types are evaluated. And actually, from the leaf node up, basically. So that's pretty neat. Set result. I don't know if that's true. And now I'll say set result value. Eval binub. Say A and B. And upcode is convert. And this is actually upcode. Sorry, binub upcode. Huh. This is in the compiler, I think. Compiler. Yeah, I hate the fact that like most code is not like very much stage specific, so it would be nice to not have stage specific file. It really would be nice to not even have files. I don't know. It's just like, or maybe if we didn't have header files specifically, then maybe I could do like a more sensible splitting of concerns, right, or whatever. Because right now there's like some things that don't really belong in anything, and I would rather just have them in separate files. But I'm not interested in adding more files since everything is like double CPP, double like CPP and H. One thing I was considering, maybe we would have 2 header files only. We would have one for publicly available stuff. So just it would be kai.h, right? Kairos.h. And we would have kai internal.h, which is only visible by the CPP files of Kairos, and it would define all of the internals of the compiler, right? Of every stage. And then the kai.h would just have like a public API for Anticatera or for CMBW. I think that architecture would work. And it would also cut down the amount of header files. Other than the problem is we have a big sequential list that the order of is not necessarily meaningful. And what I like about files is that their order is not meaningful. Like, it's not. I mean, I technically would want compiler to be between resolver and runtime. That would be neat. But outside of that, files are orderless, basically. You could treat them as. So it's not like the order of files conveys any meaning, but order of declaration conveys a meaning when you read an API, right? So yeah, it's just something to think about, I guess. Okay, we'll move it here. And now in resolver, this is where maybe I should have done that in the compiler, but then wouldn't be able to do post-tree traversal unless I wrote yet another iteration thing. I need to get rid of pre-evaluate. We'll say refactor pre-evaluate to not have redundant code. Probably merge preval and eval of expressions, and just pass. Cool. Because this is a disaster to manage. I will just forget to mirror something, or just not see that something has to be mirrored or whatever, and it's just buggy. You don't want an architecture that leads to more bugs. You want the opposite. So, okay, but now when we have eval bind up, this is where I would say convert bind up to. Need to include the compiler operation type to opcode, and this would just be expression binary up through, right? Oh yeah, resolver. Expression. Okay. And now I can do the same thing for unup. It's just we have just one unary up, expression, unary up. Unions are one of this like handy. It's a very handy feature, but the way it's implemented in C is very unsafe. It's very not. It's very much not something that is in any way safe to use, because when you can just make a lot of errors when you're like copy pasting stuff, one thing, and the other thing when you're refactoring, right? I think refactoring is like where most bugs happen, honestly. You need to refactor something to like for like the new need and for maintenance or whatever. Refactoring is not just stylistic. It's important to realize that. But it is very much not thinking is hard sometimes, you know. It's very much not optional, and it's very much sometimes difficult even because you cannot really hold every detail of the code base in your head, especially when it's big. This Kairos code base starts to become its own code base really, because this is obviously the part of Antikythera engine as of right now, but it might be worthwhile to even export it as a separate repo, especially since we'll be using it for many things. Okay. To do support compile time evaluation of functions if they are considered pure. Only if they are considered pure and without weights. Imagine if you like wrote a comp time function and it just had a weight and your compiler would have to wait that way. Be so funny, so silly too. Okay, so here's an enum. I want this to be very much optional. So like I will not print an error in case of this, I don't think. Ref name. Symbol type variable. Say true and I will say false. Expression token as an address of, okay. Symbol, and we'll say if symbol and symbol type. I guess expect is already doing that for me. Let's see break. And now what I will say is value equals symbol type, or rather symbol var type. Var type. Symbol var. And our variables that have a value, it probably should just have done as a thing. Honestly, we'll add it later. Okay, another casting thing is actually cast 2. Something from the runtime, cast 2, right? We'll make it a thing. Runtime value, eval cast. Kairos logger, runtime value. Okay. Value. Value. Why not? And then runtime type, right? Okay, guys, so basically I'm extracting this to a function because it will be called from multiple places. Logger. Actually, can't be a void. Can be void func. And now this could also be called value. Runtime, so now resolver eval unop. Yes, so what I wanted here is this. Now really just use the same thing for casting. Cast expression. Right. And I'll say eval cast. Pass it the logger. We'll pass it to volume. And we'll pass it to time. And this actually needs to be converted to runtime type. Sure, let's do that instead. We'll say runtime volume result. Return the result, and here we'll say result. Here we'll say result. Same here. Why is tick exec not? I guess tick exec is actually a static. It's not documented here correctly. Eval cast will be here. And now that also means that in runtime, when we have a code cast, that means we need to say value equals this. Or maybe even when we say this. Okay. Okay. That's neat. And how about we also do identifiers now? Oh, push one's really simple. Push one. Just pushes one. Right? Right. Without wait or async. Okay. Now basically when we have declare as a thing, that's where we should say declare your statement, declare var, and I think here I would just say result, and this would be here. It will say result value result. It's not result value, it's something else. It's expression result. So it means runtime value has to be moved up. And now here, what do we say is equals to declare value this is an expression, right? Result. Let's assume it exists, so. Right, okay. And otherwise, I guess what I can say is the type is yeah, sure, let's remove this type. So that's something I can just say here. I'm not entirely sure what's happening here. Maybe I call this value. Bar value, okay. Right. And one thing actually is if declare type. One thing here is that we want to make sure that this is const. So is const. Okay. Right. Great. Great. Okay, so now let me think about find symbol, right? So this should technically work, right? If we say value equals symbol var value. Actually, we should say it like this. Value, you'll say get result type. Right? Get result type. And maybe here should be expression result. So it was computed result value like this. And here we just say cast expression result. I don't know, because maybe I think I have to do this expression and end. No. I'll say expression result value actually. I'll say expression. If expression, then we say return expression. Otherwise 0, and that I think does it. Expression result. There's a pointer. Okay. Get the result value. Get expression result value. Like this, right? Okay. Okay, so now one thing that we need to do is actually compile this. And now I think my way of doing that is saying if expression result was computed, right? We'd go to exit in here. Or maybe we make a gigantic else statement. I don't know which one is more readable. I feel like the go-to would be more readable, but let's say with the convention, I guess. And what I would do here is I would just say this. To do should use data pooling, aka don't push the same cost twice. Should also use push 1, push 0, and push 1 when applicable. So to do for here. Okay. Yeah. And this actually means that print shouldn't be. So the problem with this pre-evaluation is the print shouldn't be here because pre-computed expressions won't exhibit any side effect, as they are just a value. Let's see, what do we get? Here, yeah, this is a problem. Not sure, maybe I should pass it as a non-pointer. Probably not, though. So what if I disable pre-computing? Attempt to bind a param of no type. That's stupid. Oh yeah, that makes sense. Makes sense why it was broken, because it's meant to be type, not value. kind of dumb, but type is a struct, but then it's also the value, the enum value. It's because this really probably should be called complex type or full type. I don't know, but we seem to be without an error now. And now when we pre-compute an expression, let's actually do that. And as you can see, unreachable code is not detected by the error handling of C. It is a warning, I'm pretty sure, though. It looks like casting is not done correctly here. And I think the reason is because actually so I think that's probably something we should support. Eval cast, so we'll say if value type equals type. It'll just return value like this. And this is mostly for compile time stuff, right? But we also don't emit those casts. Kairos, no. Huh. Kairos, no. Haven't I initialized the resolver? Unless the order here is incorrect. But then it is actually correct. Okay. So let's see what happens here when we do a pineapple. Upcode is upcode 21, which is upcode should have made that. Should have made that explicitly the type of that. It is multiply, okay. The type is this, right? Multiply. Let's see what where this is. Oh, exec logger is not. Oh yeah, right. It's my bad. And the reason is I have to just init exec runtime. Okay, I think that does it. I bet that means that it was like a wasp pre-computed. Was pre-computed, right? Oh, yeah, this is wrong. Should be resolved pre-computed value. Yeah, that seems to work. So now if I say, this is actually great because this in compiler means even more nice stuff, and it means global. Set global, right? When we declare, we say this normally, but actually now we say result was pre-computed, and then we say expression result pre-computed value. Yeah, it's neat. That means that things that are trivially pre-computable. So if I say, actually I kind of want to also say is constant. I want this because some things are. So I want the globals, the pre-computed initial value to always be here, right? But for when we do this, we actually only care if pre-computed value was also a constant. Is constant. Okay. And now the way we will set the constant is probably through this. But first I will look up identifier values, right? This. My symbol actually declared type is what I'm thinking of. Here I would say, instead of saying this, I would just always say this. And then I would say is constant. Wait. Distance equals this. Yeah, so I guess I could say is const. Is const. And now in resolver, when we set result value, is I would actually want to pass is constant, is const, and then in this case, I'll say if above we'll have a result bool set runtime value. This is what I need. Honestly. Let's go with this value. This is confusing. Shouldn't be called the result for sure. Expression result. Value equals pre-computed value, right? Value. This is this const, and then set is equals to true. And then this would be a is const and b is const, right? a value, b value. And maybe what I say is actually just not have a set pointer at all and just have this. Pre-computed value, we'll say a value and b value. Right. Say value. So stupid. Anyways, value. Value is const. Result value, good result value for var. Var value, right. Value is const. Here we just always say it is. For enum values as well. For casting. Result value. And for this, I'm pretty sure we say value is const. Because if we know something's constant, that means we can be sure we can use its side effect, right? And actually for print, maybe is const is actually should be is pure. Should we say is pure instead? This is better that way. I think so. I know constant doesn't really matter. Line. Okay. So now somewhere is const, we'll rename it to is pure. And we'll say is pure equals is pure like this. Pre-compute, yeah, okay. Okay. Right. Okay. That means print can go back here. Print. Or someone like this. We'll just say count. Is there actually any time? Huh. Is there any time where you want a pure? Is there any time where a non-pure variable would be useful? Because I feel like that's probably a bit goofy. Then, like, I don't think that's really useful right now. Compiler is pure. So we can't really use a non-pure value anywhere anyways. Right now. This also has to check for expression result is pure, which makes it kinda stupid. I don't think I even needed the iscons. That was actually a misjudgment on my part, misunderstanding of the problem. And now what I do is I just remove the only non-pure thing that we currently have, which is this. Fine, and now is pure can be removed like this. This can be back to this. Here we return this, return this. Good, we're gonna have to do that, I think. We'll say dot value can just be removed from time value. Okay, result value. Okay, I think that makes us whole. And does that work? Yeah, it does, right? I don't know how to test this really. My var 3 times 3 times 3. My var and my var. What I probably should check is see on runtime. We should check. Should check something, right? Should check Where are we? When we learn, so maybe doesn't test, right? And at runtime. Let's look here. Now let's check our global memory. And it seems like some things were yeah, it seems like they were pre-computed. There's one global that seems to be empty, but let's see what we get after execution. So program globals. The global 2 seems to be none, which is concerning. Also, but let's maybe update the list first. What's up, Roshi? I was about to end, so I need that you're here. But I've been able to. Alright. Yeah, and done some stuff, and I can take a break soon. Just need to finish up, set this up, and document some things. I would want to investigate why that one global is 0 though. Not sure. So whenever we allocate a global, okay, let's see, set global, right? And that's, I'll have to check in compiler. Right, whenever we declare it, let's see what happens, or rather, if it's a global. Let's see, var. Okay, so let me think about this. There's test global. Test global seems to be the broken one. Test global. It's weird. It seems like a normal global. It does seem to work. I don't know what's wrong. God damn it. Chasing bugs always the most annoying. Okay, let's see. Oh, printed tick, by the way, should probably be. Oh, no, maybe not. Let's think about this. Okay, so let's look at our program. Exec runtime program. Globals. Oh yeah, there is 10. 16, there's also 3. These numbers taking a slot. Oh, okay, this is all correct. This just doesn't. We just have some code that doesn't have. I don't know why this is not in the errors. Okay, that is an unknown problem that I haven't fixed yet. But that's actually it, so. Progress from stream. It's pretty nice that we have this already. I don't think I'll be able to do it so quickly. But pre-compute what can be pre-computed. Refactor logging. Okay. Neat. Okay. I'll see you guys tomorrow, as always.